looking at your study guide, the entire first page, you will see every question either has an inverse or an arc in it. Those mean the same thing. They are inverses. The answer to an inverse is an angle. If you have an inverse, how many answers can you get? Only one, because remember, functions have to be one-to-one to have an inverse. So, this whole first page, if you're dealing with inverses, that's when we limit our quadrants. We need a positive quadrant and a negative quadrant. Everything's positive in quadrant 1. Some of them are, yep, so then we could do 1 and 2 or 1 and 4. All right, so if you take a function, so sine. Sine is positive in 1 and 2, correct? Yeah. So if I'm looking for a positive and a negative quadrant, it has to be 1 and 4. And we know its inverse does the same thing. Or sorry, its reciprocal does the same thing. Cosine is positive in 1. When is it negative? 2. So cosine inverse and its reciprocal, secant inverse, are in 1 and 2. Tangent and cotangent, they're both technically negative in 2 and 4. So we go back to how we graphed them. When we graphed tangent, we went from negative pi over 2 to positive pi over 2. So that was quadrants 1 and 4. So it goes along with the sine. Cotangent, when we graphed, we did 0 to pi, that was quadrants 1 and 2. So cotangent inverse is in 1 and 2. You have to know this, but we only apply it if the original problem has an inverse. Okay, so sometimes we end up using the inverse button on our calculator to solve for something, but if the original problem didn't have inverse, then we're dealing with every quadrant. It happens.
I remember writing stuff in all caps. And
yes.
Not even doing it.
Yes, it's very important. Okay, so let's look at the first ones then. It said 0 to 2 pi, so we're talking about radians. So we have cosecant inverse of negative radical 2. So when I see cosecant inverse, that does what sine does. So it could be either quadrant 1 or quadrant 4. What this means is that cosecant of some angle is equal to a negative radical 2. If it is a negative, which of those quadrants is it in? 4. Okay, if you're not familiar with cosecant, that means the reciprocal sine is 1 over that, so radical 2 over 2. So when is sine radical 2 over 2? What's our reference angle? 3 pi, which is pi over 4. So pi over 4 in quadrant 4, you could say negative pi over 4 or 7 pi over 4. Right? Remember, you can use a unit circle as long as you can fill it out. So I will have blank ones, but you have to be able to fill it in. All right, so when I see arc cotangent, that's the same as cotangent inverse. Cotangent is 1 and 2. What this means is cotangent of some angle is negative radical 3 over 3. If cotangent is negative, which of those are we in? 2. All right, reference angle. If you don't like thinking about cotangent, that means tangent is the reciprocal, which is radical 3. Reference angle. When is tangent radical 3? 60, which is pi over 3. So then pi over 3 in quadrant 2 would be 2 pi over 3.
Okay, 6 over, okay. I just can't do math.
So problem 3. We have y equals arc secant negative 1.5. So arc secant, that goes along with cosine. So that's 1 and 2. This means secant of some angle is negative 1.5. If it's negative, we are in quadrant 2. If you don't like secant, that means cosine is 1 over that, or negative 2 over 3. To get our reference angle, because we don't know this one, first of all, we're in radians, so make sure your calculator is in radian mode. And then we do cosine inverse, positive 2 over 3. gives us 0.8411. Then how do we put that in quadrant 2?
180 minus
That's
pi.
pi minus.
Whoops.
I get lost.
And so we get our angle to be 2.3005.
Do we, like, if we accidentally, like, for example, we wrote down the reference angles as 0.8411, but we actually just plugged the whole decimal into your calculator instead of just doing that and it rounded differently, would that be a fault on our part?
No, as long as I can figure out where your
Would
answer
it just be
came
like
from.
maybe a one off?
Yeah,
rounded
It would
off?
just be the final decimal. Other questions? You not good at that?
But I wrote 5 down.
So we have tangent of arc cosine 3/4. Okay. As soon as I see this, I know I'm not dealing with every quadrant, right? The answer to an inverse is an angle. So I'm just trying to find tangent of some angle. Now, unfortunately, do we know when cosine is 3/4? No. So we don't know that one exactly. However, cosine inverse can be in which quadrants?
1, 2,
If it's a positive 3/4, we're in quadrant
1.
1. So this is like saying cosine of theta is 3/4. So if we drew our triangle in quadrant 1, cosine is adjacent over hypotenuse. So we can do Pythagorean theorem. 3 squared plus b squared equals 4 squared. Since it's first quadrant, that would be a positive radical 7. So then tangent, SOHCAHTOA, opposite over adjacent, would be radical 7 over 3.
I forgot that we had a triangle.
Yes.
I hate triangles.
On those, I would probably specify that had be the exact value on the test so that you weren't trying to just use the calculator. All right, problem number 5. Sine inverse. So as soon as I see that, I know I'm not dealing with every quadrant. Sine inverse can be which quadrants?
1, 4.
Okay, but this inside we can evaluate. Tangent of pi over 4 means the tangent of 45 degrees. So radical 2 over radical 2 is 1. So sine inverse of 1 says, tell me the angle when sine is equal to 1.
90 degrees. So
90 degrees.
pi over 2.
And I did not tell you in the directions if you had to use gradients or degrees, so either would be fine.
Sometimes I'm so fast it goes on like the line, and sometimes like
Sometimes it takes a
half of these,
second.
well, half of them I did them wrong because I didn't realize I thought sine was x.
Gotcha. Alright,
I don't know why, but sine just feels like it should be x.
go alphabetical. Cosine comes first.
Oh,
So cosine is here.
cosine. Okay, all right.
Okay, so when I look at this, tangent inverse, I see this and I know it's not every quadrant. Tangent inverse can be,
1 and 4.
so reference, that means we have to find the angle
I'll put it on the thing.
so that tangent is -1/5.
Triangle.
So which of these quadrants are we in?
4.
Alright, and then once we find that, we just have to find cosine of that
That's
angle.
called triangle.
Okay, so in quadrant 4, tangent is opposite. That's the side going down, so that would be my negative over adjacent. And you do a squared plus b squared equals c squared.
Radical 6. Oh, I can't square.
So cosine is adjacent over hypotenuse. So we get 5 radical 26 over 26.
How many?
That one okay?
Yeah. I have a space in my big notebook.
Alright, problem 9.
What I did wrong here was I actually just thought that I could just put sine of 3 in my calculator. Because I love sleeping as well.
Okay, so if I look at this one, do we have a greatest common factor?
You know,
No, but this is like a quadratic.
quadratic.
Now, also looking at this one, does my original problem have any inverses in it?
No.
No, so we are dealing with everything on the circle. We are only limited if the original problem has inverse. So, yeah. So sine squared we break into a sine. What two numbers multiply to -3 and add to -2?
-3 and 1.
Okay, so if we set each of those equal to 0, we get sine theta equals 3 and sine theta equals -1. Can sine be 3?
No.
No, even if you try putting it in your calculator, what's your calculator going to tell you? Domain error. It's not possible. Sine can only be things between -1 and 1.
Mine didn't.
I also typed in something wrong. Or you did sine instead of sine inverse. So this isn't possible. This, we're thinking about a unit circle. Sine is the y. When is y -1?
270.
So our angle is 270 degrees. Problem 11.
Get the cosine bites.
So get our function by itself. So cosine theta is negative radical 2/2. So it's not an inverse, so I want to know every time cosine is a negative.
Oh, yeah.
So I'll have an answer for each. Reference angle. When is cosine radical 2/2?
45 degrees.
So in quadrant 2, 45, so 180 minus 45.
They're 130.
In quadrant 3, 180 plus 45.
225.
And that would be our final answer. Is this making sense, guys? Helping at all? Number 13. Alright, so when I look at this one, you have a function squared, you have a function to the first, so your first thought might be trying to like factor it like a quadratic. However, it doesn't work because they don't match. We have a secant and a tangent. So we need to go back to our flip chart, all of our basic identities. What can you change secant squared to?
Tangent squared. Tangent squared plus 12.
And when you do that, the angle stays the same. So this is tangent squared theta over 2 plus 1. So now I'm going to rewrite it. I'm going to put my tangent squared first. And my tangent. If I subtract over my 3. So now we have something squared, something the first, and we have a constant.
Now we can put on that.
So tangent squared breaks into a tangent. The angle doesn't change. Remember, you can't change these angles unless you're using like a double angle formula or something. Those never change. Two numbers, multiply to -2, add to -1.
-2 and 1.
So if we set those equal to 0, we get the tangent theta over 2 equals 2.
But they're too big.
And tangent of theta over 2 equals -1.
Too big.
Tangent can
Oh,
be anything.
wow.
In which quadrants is tangent positive?
1, 2, 3.
Reference angle. Do we know when tangent is 2? No. So we are in degrees. So flip over into degree mode. And we do tangent inverse of positive 2. We get 63.4349 degrees. So that means my angle. So whatever this angle is, carries down, can equal. In quadrant 1, my reference angle is my angle. What would we do for quadrant 3?
Add 180.
Mm-hmm. So those are the answers for that one. Over here, tangent is equal to a negative. And what quadrants is tangent negative?
2 and 4.
Reference angle. When is tangent 1?
40.
So 45 degrees in quadrant 2. So 180 minus 45 is 135. Quadrant 4, 360 minus 45. But we are not done. Why?
Because we have to get it multiplied by 2.
Yes, we're solving for our angle. So I have to take every one of those times 2.
If we recognize it's going to be too big before we even multiply, do we have to structurally multiply it?
You better make sure you're not wrong.
Well, I know that 2 times 2 is bigger than 3. It is, I promise.
Now, if I had said all possible solutions, we would keep everything here. And what would we have to do on each of them?
Plus 360k.
But the directions say give me the answers between 0 and 360. So if I'm only wanting the ones between 0 and 360, these are too big. So I would only keep the 126.8698 degrees and the 270 degrees. So just make sure you are watching your directions on these. We are still solving, but I switched over to radians. Right, what would we do first?
Get everything on one side.
I'll subtract my 3 cosine x. What do you recognize? Slip and slide. This is a quadratic, but we have a coefficient, so you have to bring that down. So what numbers multiply to a positive 2, add to negative 3?
-2, -1.
Now what do we have to remember?
Divide.
Divider 2. So cosine x is equal to, whoops, cosine x minus 1. And 2 cosine x minus 1. Alright, then set those to 0, so cosine can equal positive 1, positive 1. Is everybody with me there?
Mm-hmm.
Okay, when is cosine 1?
0 degrees.
0 degrees, but we're in radians, so that's 0 radians. Yes. No degree symbol. When is cosine positive?
1, 2. No, 1 degree. 1 and all is 4.
1 and
Can't
4.
count.
Reference angle, when is cosine 1/2? Pi over 3. So pi over 3 in quadrant 1,
Yeah, pi over 3.
And in quadrant 4,
5 pi over 3.
is there a way to check your answers on these guys?
Plug it back in.
Yeah, go back to the originals and plug them in. They should get it to work. Are we okay with 14? If I said all possible, what would change?
Plus
That's
2
plus
pi
2
k.
pi k.
Plus 2 pi k on each of them. And you would have to make sure you tell me k is
An integer.
an integer.
Easy.
K is an element of the integers. Alright.
And then if it was like a x over 2, it would be 4, or no,
Yeah,
it would be 4 pi k.
Mhm. Okay, this one is a problem.
Okay.
When I look at it, not only do we have two trig functions, we have two different angles. We have a 2x and an x. When I see that, that's when I'm going to try to use an identity. So we have a double angle formula. We actually have 3 of them for cosine 2x.
We just want the one side.
We want the one that involves sine. So cosine 2x is 1 minus 2 sine squared x. So set it equal to 0, so I'm going to add over my 2 sine squared x, subtract 1, and then, very similar to the last one,
So it's like
slip and slide. So that's sine x minus 1, sine x plus 2, very familiar here. What do we do now?
gotta divide by 2.
2 sine x minus 1 and sine x plus 1 equals 0. From here, we just set each of them equal to 0. So that means sine is a positive 1/2 and a negative 1. Alright, when is sine positive?
1 and 2.
Reference angle, when is sine 1/2?
It's just 30.
30 degrees, which in
Pi over
radians?
6.
Okay, so pi over 6 in quadrant 1 is pi over 6. In quadrant 2, that would be 5 pi over 6. When is sine negative 1? Think about on the unit circle. Sine is your y, so y is negative 1 at
3 pi
3 pi over
over.
2.
My issue I learned is just that when I hear 30 degrees, I think it's
Pi over 3.
pi over 3.
So if you just slow down a bit,
I won't.
you won't slow down or you won't get it.
I won't slow down. My brain goes too fast.
Okay. Problem 16. This is one everybody needs to pay attention to. Okay. What's the first step?
Get everything on one side. Or no, because it's not squared. You just gotta get set the sign equal.
Okay. When I add this over, does it become sine 6x?
No,
No.
2 sine 3x.
Okay, angles don't change. Unless you're like using a double angle formula to replace it. So sine 3x becomes a negative radical 3 over 2. First,
Pardon?
2 over 2. First of all, if you have a triple angle, that's what got me. I was thinking of the next thing I was going to say. If you have a triple angle, what does that tell us?
Yeah, triple the solutions.
Okay. Quadrants. When is sine negative?
3 and 4.
Reference angle. When is sine radical 2 over 2?
Pi over 4.
So my angle, which was 3x, could equal pi over 4 in quadrant 3 would be 5 pi over 4. In quadrant 4, right, but how do I get the rest of them?
Add 2 pi.
So if we get them right now, we add 2 pi. We have 2 solutions. If we're going to triple it, we have 6 total. So 5 pi over 4 plus 2 pi. If you're doing it on the calculator, you just don't do pi's, or you could think 2 is like 8 over 4. So that's 13 pi over 4. If you add it again, that's 21 pi over 4. 7 pi over 4 plus 8 pi over 4 is 15 pi over 4. Add it again, that's 23 pi over 4. So we took care of the triple solutions. Then what do we do? Alright, or multiply by 1/3. So we get 5 pi over 12, 7 pi over 12, 13 pi over 12, 15 pi over 12 reduces to 5 over 4. 21 pi over 12 is 7 pi over 4. And 23 pi over 12. Alright, so that one had a lot of solutions to it. Everybody take a look. Do we have questions? Yes.
How much will be taken off if we forget to simplify?
So you have all the answers, just not in lowest terms, probably a half point. Other questions? Problem 17. Alright, this one is not pretty. First of all, it's a 2x. So you could use a double angle formula if you really wanted to, or we could just tell ourselves we will have double solutions. Okay, sine is already by itself. Quadrants, when is sine positive?
22.
Reference angle, do we know when sine is 1/4? No. So we use our calculator, flip it into radian mode. And we need to do sine inverse of 1/4. So second sine. And we get 0.2527. So my angle, 2x, could equal, in quadrant 1, my reference angle is my angle. How do we get it in quadrant 2?
180 minus.
Pi minus.
Oh my gosh.
Yeah, so we
I
have
was
to do
wondering why that
pi
got so
minus.
big.
But double solution, so how do I get the next two?
Add 2 pi.
Add 2 pi to each of them. Okay, so then we have our 4 answers, but we're not done. What do we have to do? Divide every one of them by 2.
Oh, my numbers are gonna be out of order. What's that?
I'm sorry. Trying to be nice and utilize my time. Okay. There's a couple ways of doing this. A few of you caught it yesterday. A function and an inverse do what?
Cancel.
They cancel each other. So if you recognize that, sine and cosecant inverse, you might be able to get to the answer from there. If not, you could do it the same way we did the others.
Wait, how would
We
that-
know,
How would that work?
I'll show you in just a second. We know this is an angle. Cosecant inverse could be in 1 or 4. Since it's negative, it would be 4. So we know cosecant of our angle is -2. We have to find sine. So cosecant is hypotenuse over opposite. The hypotenuse is always positive, so the negative would go with our opposite. If you do a squared plus b squared equals c squared,
A squared equals radical 5. Right, equals radical 5.
that's
Oh my gosh, A equals radical 3.
And then if I ask you sine, opposite over hypotenuse, nope, that's cosine. It's just a negative 1/2. If you had caught it from the beginning,
I understand what that is.
cosecant inverse would be the same as sine inverse of negative 1/2. And those cancel and just give you the negative 1/2. So 2 ways there. Either one will get you the final answer. Problem 8. What would you do?
Take out a cosine.
Not yet.
Oh, put it on that side first.
Mm-hmm. So then if we take out a cosine, we get cosine squared minus 1. So if we set those to 0, so cosine equals 0, that's just from our unit circle. When is cosine 0? That's like saying x is 0.
Was it 0 and what? 90 and 2/7.
90 and 2/7. This one says cosine squared is equal to 1.
So then it's when you place 0 on the negative.
So if you do a square root, plus or minus, cosine is positive or negative 1. So cosine is positive 1 at 0, negative 1 at 1. I might take off a half only because the directions say this. 0 and 360 are the same point, but you notice I put the bracket on the 0 and a parenthesis on the 360. So they are the same, but the directions are telling you if it comes to that point, use the 0. 360 is technically outside our interval. Sorry.
So we get the 359.
Think I'll get through the last 2, then I'll work the entire study guide with you.
Let's do it.
Oh, yeah. Oh, yeah.
No excuses. You guys will be prepared.
Sure.
What would you do?
Half the sine of
Subtract it over and factor it. Okay, set them to 0. Because it's a 3 theta, what does that tell us?
triple the solutions.
Okay, so sine is 0. That's saying y is 0. That happens at 0 and 180. Cosine is 1, happens at
Just
0. Okay, get your extra answers. So you add 360 twice because we need triple. And then to finish, divide everyone by 3. I lost my train of thought. Let's see. Where are we at? And those will be our answers. And number 12.
Oh, we got time, baby.
Okay, so if I subtract over sine, it's not the angle that changes, it's the coefficient. Divide by 2. In what quadrants is sine negative?
3 and 4.
Reference angle. When is sine radical 3 over 2?
60 degrees.
So my angle, x over 2, could equal,
240.
in quadrant 3, 180 plus 60, 240. In quadrant 4, 360 minus 60 is 300. But to finish it, we have to multiply by 2. So we get 480 and 600. But what's wrong with that?
Neither of those work.
Right. I asked for only answers between 0 and 360. So there are answers, but just not in my interval. So for the directions you were given, it would be no solution. Now, if I said all possible, then we would keep them.
I put a question